Causes and laws of refraction. Students, you have seen that a straight stick seems to be bent when it is half dipped in water. You know that it is because of refraction of light. Can you tell me why the refraction occurs? Here, in the above condition, the stick is dipped in water and our eyes are in the air. So the light from the dipped portion of the stick travels to our eyes through two different media. As you know, light travels with different speed in different media. Thus, the speed and the wavelength of a light ray changes when it passes from one medium to another. Due to the change in the speed and the wavelength, the ray of light bends at the point of contact between the media. This is the actual cause of the refraction of light. Laws of refraction. Students, let us perform an activity. Take a stick and dip it partially into a beaker of water in an inclined position. What would you observe? Yes, the stick seems to bend at the surface of water. Now hold the stick in a vertical position that is making perpendicular to the surface of water and observe. Can you see the stick bent now? No, the stick doesn't seem to be bent. Can you say why this happens? This is due to the fact that the stick is vertically straight and the light rays emerging out of it pass normally, which do not get refracted. This phenomenon is explained by laws of refraction. There are mainly two laws of refraction. The first law of refraction says that the incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane. Students, incident ray is the ray of light entering from one medium to another. Refracted ray is the ray passing through the second medium after refraction, and normal is the perpendicular to the surface separating the two media. Here, AO is the incident ray, OB is the refracted ray, and MN is the normal at the point of incidence, O. The second law of refraction says the ratio of the sine of angle of incidence to the sine of angle of refraction is always constant for a given pair of media. Mathematically, sin I upon sin R is equal to mu, where mu is the constant called refractive index. Students, I is the angle of incidence. It is the angle made by the incident ray with the normal. R is the angle of refraction. It is the angle made by the refracted ray with the normal. Here, angle AOM is the angle of incidence and angle NOB is the angle of refraction. This law was given by the Dutch scientist Snell van Rooyen and is also known as Snell's law. Students, the detailed illustration of the Snell's law will be discussed in the higher grades. Here we discuss the key points that can be understood from this law. These are: 1. When a ray of light passes from rarer medium such as air to the denser medium such as water, it bends towards the normal. In this case, the angle of refraction R is smaller than the angle of incidence I. 2. When a ray of light passes from denser medium such as water to the rarer medium such as air, it bends away from the normal. In this case, the angle of refraction R is greater than the angle of incidence I. 3. The ray of light passing through the normal does not bend. In this case, both of the angle of incidence and the angle of refraction are 0. In this case, both of the angle of incidence